Hello and welcome to this video where we've come into object-oriented programming. Inheritance is a very interesting property in object-oriented programming that you can reuse code in a special way so that you inherit the attributes and the methods from your parent, and that parent inherits from the grandparents, etc., etc. However, you should not create so long inheritance chains, because when you do that, the code becomes a spaghetti code in a very easy way. So there's something else called composition that also talk about. So when you have inheritance, an is a relation, while a composition is a has a relation. And what this means is that in an is a relation, there's much stronger coupling. For example, a student is a person, so then a student inherits from the person, and the person class should have some basic properties, basic methods and attributes that are common for all persons, right? Because, for example, a student is a person, a teacher is also a person, but a student and a teacher have different attributes and different methods that they don't share in common. So only those that they share in common should be in the person class, right? And the rest should have their own methods and attributes that are common for that particular type. And for composition, however, for example, a classroom has several students, right? It has students, so it's a has a relation, and a classroom has a teacher, right? So then what you do is basically that you instantiate an instance from a class within another class. So it's a more decoupled. So it's not like a classroom. A classroom has students, right? So this is a has a relation. Okay, so let's move on to some code in Visual Studio Code. So here I am in an empty folder, and let's create a virtual environment, and you should definitely work in a Git and GitHub repositories. Create this if you don't have a virtual environment already. That is, otherwise it will overwrite your UV if you already have your UV VNV. So let's activate it. So source.ven bin activate, and now I've activated my virtual environment, and let's install UV pip install. The only thing I need is ipykernel, I think, to work with Jupyter Notebook. So now I can close this down safely. So let's open a new script here, or a Jupyter Notebook, inheritance.ipnb. Okay. And I will also need to have this, I will also need to copy this over. So oldcoins.py. So copy this from the last lecture where we have worked with the old coins, or the one with, I think it was encapsulation, right? So here we have the old coin stash, because I need this, I will import this into my notebook. Okay, so let's go into inheritance here, and inheritance in OOP, and change this to Python OOP like this. Okay, so let's start with a person. Class person. So this is a base class containing generic methods that are shared by all subclasses. So I'll give it a docstring like that. So this is a base class. They have generic methods and attributes that are shared among all subclasses. All subclasses are the children, right? And this base class is the parent. This is how the relation is done there init. Let's see, what do we need? We need to have a name. This is a string. We need to have age. This is an int. And it should return none. Okay, so I've made some type hinting here. So self.age equals age, self.name equals name. And now I will also go into something that I forgot to mention in encapsulation. I forgot to mention property. So then I will bring that up now. So property is a way for us to hide information and hide the implementation inside of the property while we expose a certain interface to the outside world. So what we do is add property, def age, self, it returns an int, and it should return self dot underscore age. Okay, so remember that it returns a private variable now, while when we put in an age here, it will go into a public variable. So how does this work? It works like this. So let's just start simple. So person of, say, Bella is not a person, but it no matter. 4, what will happen? We'll get an error here. So this is expected. We get this error because this attribute error because property age of person object has no setter. So this means that when you put in 4 here into age, it will actually go into when it will call self.age, and then it will look for this property. And this property, it doesn't have any setter. This is a get only property as it's written right now because we haven't written a setter. So that's why we get this error, this attribute error, because we cannot set this age. Okay, so how to do this? I'll copy this one. I'll put it in new code here. And what we need to do is add a setter. So age.setter def age self comma value. Value should be an int. Return none. Self dot underscore age equals value. That's it. And now if I run this one, no problems. It has set it. So what I can do is that, for example, person1 equals this one, and then I can do person1 dot age, and you can see 4. Because 4, it will choose to get there. So if I just run this one, you'll see first we'll have setter run because of this, and then we'll have getter run because I'm doing person1 dot age. If I do person1 dot age equals 5, then you can see that setter is run. Because the setter is run whenever we're assigning a new value, while the getter is run, which getter is run whenever we're retrieving that value. Okay, so then you might think, why do we do this? This seems to be so much code for doing the same as just having the plain the bare attribute. We could just have the self.age. Why do we need to do all this trouble? The thing is, by doing this, we can add some different things in our property that should be hidden from the outside world. What can we add? We could add validation, for example. It could be a computed property so that it could compute things that needed, or doing some different processing. So for example, if not is instance of value, comma int, for example, we could raise type error. Age must be int or float, not type of value. Okay. And if I put in, for example, so I run this one. If I put in, for example, 4, 5 like this, you can see we get the type error. So now I've gotten this validation here, but I could also add another validation. If value is not within this range, we could raise value error. And for example, if I then write 5, that is okay. But if I do -5, that is not okay. Value error, and you can see this not valid. Okay, so what it does is that this becomes more powerful now. We have controlled the age property. Now it becomes, instead of having the bare attribute age that you can change to whatever you want, now we have control over it. We can make sure that it gets the value that we want it to have, right? So this is quite powerful by using properties. So this was what I wanted to talk about in the encapsulation part, but I forgot to mention this. Now I just mention it in inheritance so that we will use this. Okay, so let's copy this code here and continue creating some inheritance now. So I'll make a property of name as well, and I'll just explain the code. So what this does is that, we have a name property as well. And this is the getter, and this is the setter. And here we do a re, which is regular expression. So I need to have import re. So this is a regular expression that I won't explain in detail, but what it does is that it makes sure that the name has all possible letters in the alphabet, and it will have a space, and then it will have all letters in the alphabet, and then it will end. So it starts with several letters with the plus here, and then it will have several letters in the second one, and then it ends. And it could have several spaces and several names, so that it's possible to have not just a first and last name, instead a lot of middle names is also okay. So that is the idea of this regular expression. So then if this doesn't pass, then we will raise a value error and say that it's not a valid name. So basically just have a property for the name, right? And then have a say hello, say hi, which says that this person says hi. So if I do p1 equals person Greta, and you are, say, 20, and then we say p1 dot say hi, set the run. Actually, I don't need to have this code anymore. I'll remove this get the run and this set the run. Let's see, set the run. I run this one, and it says person Greta says hi. And now let's inherit this code so that we get all these things for free, all the properties here for free. So what we can do is we create a class student. It inherits from person. So a student, let me give it a docstring, a student is a person that knows a language, let's say that. So def dunder init, and this one should have the name, string, and age string, age as int, and language string. It should return none. And then what we do here with super is that we call the parent class, and then you place in name and age, and then you have a language as well. So then we do self.language equals to language. And here, of course, this language, we could add some validation for that as well, but I will skip that to make it simple. So we say def say hi. So when I do this, what will happen? What will happen is that it will override the say hi method. So overrides say hi from the parent. And when it's overriding, it means that when you call an instance that is a student and use the say hi method, then it will look for say hi method within the student. And if the say hi method doesn't exist, then it will look into its parent and see if say hi exists. And if it exists, pick that one. But if it does exist in the student, then it will pick that one, because this has higher precedence. So let's do this. So return, or instead of return, say just print. We say student self.name knows self.language. Okay, so you can see we take self.name. Why is that? Because we have the name property and we have the age property from the parent class. We don't need to add an age as well. Self.name, student, self.name is self.age, years old, and knows this language. So if I say a student now, S1 equals student of Örjan, you are 25 years old, and what language do you know? Python. And say S1, let's say hi, and you can see student Örjan is 25 years old and knows Python. So note that it takes the say hi from the student, right? And then the student, it takes self.name, the property, from the parent. It takes self.age from the parent, self.age, language from itself, right? And then we can continue now. I will create another class called Viking. And a Viking is also a person. And a Viking has an old coins stash, but it's a composition we're talking about. So it has a relation. It has a old coin stash. So what we need to do is we need to import it. So from old coins, import old coin stash. And def under init, let's see, name string, age int, returns none, name age, yes, and then self.stash equals old coin stash. And what does old coin stash need? It needs an owner. So I will just place in name. So let's say, let's create a Viking now. Viking of Ragnar in v1. v1.say hi. Let's see, it says required positional argument. Okay, how old can you be? 54. And it says person Ragnar says hi because it doesn't have a say hi method. It has one from the parent class, but it doesn't have, it haven't overwritten it. So you can also do v1.dunderdict, for example, and see what we have here. We have underscore age 54, underscore name Ragnar, and we have stash as old coin stash. Why is that? It is because remember that the property, it will have the backing variable as underscore age and the backing variable underscore name. And it has a stash, which is an old coin stash, and this stash is, it's not a property, it's an attribute. Okay, so this was inheritance. So in this class, we've seen inheritance and we have seen properties. So we started with properties where we could hide the implementation details, such as validation code, for example, so that you only show the interface that you want to show to the outside world, and then the rest is hidden. And for that we could validate several code. We can do some computation, and then we went on to inheritance, where we inherited the code from the parents, and as you've seen there, there's a lot of all the attributes and methods from the parents can be accessed in the child. And in the child, if you use the same name as for a method, then it's overwritten that method. And when you call that child's method, then it will choose the child's method. But if it doesn't exist, it will look into it in the parent class. And then we also went into composition, where we created another class so that it's more decoupled. So it's not as strongly coupled as in inheritance. And in general, you should favor composition over inheritance. But in some cases where there's a really strong relation, then you should choose inheritance. Yes, and after you've seen this, you should definitely commit and push your code to GitHub. And I hope that you've learned a lot. See you in the next video. Bye.